In today's video, we'll be going through the 2025 paper. It's the mid-year paper, May-June of KZN. We'll be looking at paper 1 and specifically on question 2, which is Newton's laws and application of Newton's laws. So yeah, let's get into it. So we have a block of mass 15 kgs is pushed up an incline with a horizontal force of F, as shown in the diagram below. The incline makes an angle of 30 degrees with the horizontal. Then they say the coefficient of the kinetic friction between the block and the surface is 0.2. They ask us at 2.1 to find the term kinetic frictional force. Kinetic frictional force is the force that opposes the motions of a moving object relative to a surface. Then, question 2.2, we're asked, draw a labeled free body diagram showing all the forces acting on the block. So let's say we have the block, like so. We'll have weight trying to pull it down. We'll have the force pulling it in that direction. We'll have the normal force perpendicular to the plane. And we'll have frictional force opposing the direction of movement, so kinetic friction. Said we have, this is the normal perpendicular to the plane. We have weight, and we have the force being applied to the block. And then in 2.3, they say the block moves up the plane at a constant velocity meaning acceleration is 0. They say in 2.3.1, state Newton's first law of motion in words. Now, Newton's first law of motion says a body will remain at a state of rest or motion at a constant velocity unless a net zero resultant net force acts on it. So 2.3.2, we then have to calculate the magnitude of the force F. So we were told that the block moves up the plane at a constant velocity, that's that direction, at an acceleration of 0. So you know what the sum of forces in the direction of movement we now know have to be equal to 0 because F equals ma, but a is 0, so ma is equal to 0. So let's try focus on the plane of movement here because it will be easier to get all the directions of movement. So if we had to say the plane of movement is our x-plane, that means the perpendicular plane will be our y-plane, and therefore our free body diagram to analyze that surface will be something like Fk being opposing the movement in that direction. That's our frictional force. Our normal force would be directly upwards. Our force being applied will be 30 degrees downwards. So our force being applied, and our weight will be tilted 30 degrees in that direction. So say 30 degrees that direction. So that's the free body diagram that I'm gonna work off of just to analyze the net force on the object. Let me just shift this up. Okay, so let's analyze the sum of the forces in the x direction. Now, remember we're using this plane, the plane of movement, as our x plane, and the perpendicular plane to the surface as our y plane. So in the x direction, let's take left as positive. Remember, it's moving in a constant velocity in that direction. So ma equals 0. Therefore, 0 equals, let's start with, we said left is positive. So let's start with the x component of this f. That is, we'll use cos to get the x component. So f cos 30 degrees. And then what do we have here? We have weight, right? So we're going to find the x component of weight. Here we'll use sine because it's opposite of the angle. So minus w sine 30 degrees, and then subtract this component which is directly in the x-plane, so minus fx. So if we want to leave f as a subject of the formula, we can take w sine 30 and fk to the other side of the formula. We'll have w sine 30 plus fk, and that will equal f sine 30. So it's a problem. This was cos 30. That's cos 30. We can get the values for sine 30 and cos 30, but in the meantime, let's work with our unknowns. We have w over here, which is weight. Weight is equal to mg. Our mass was given to us there as 15 kilograms. So 15 kilograms for m, 9.8 for gravity. That should be given to you in your variables with your paper. This should be 147 newtons. Let's see, what other unknowns do we have here? We have fk. So fk, frictional force, kinetic friction force, is equal to mu k, which is our kinetic frictional force constant, times n. So now we have new variables, which is mu k. The constant has been given to us, kinetic friction constant, coefficient of kinetic friction as 0.2, and n is this component. Where's n? Didn't write n there, but that component, that force over there. In the y-plane, we know that the block does not move down the plane. Therefore, this f component in the y direction and this weight component in the y direction equally opposes the component of n. What does that mean? It means that n is equal to the y component of f. So f, the y component is opposite the angle, so sine 30 plus the y component of the weight, which is adjacent to the angle, so weight cos 30 degrees. Alright, so we got the value of n, we got mu k. We still have n as a function, so we'll substitute that in. Let's go back to the equation where we needed fk. That's this one here. So we have weight, it's that value, we can calculate sine 30. We have fk as a function because we can substitute mu k and n, and f is what we need to find, cos 30. So we're almost there. Let me write in the values of this equation down here. So let's do that. W equals 147, so 147. Then we have sine 30, which I can calculate now. Actually, we'll calculate that all together. I think that'll be easier. So sine 30 degrees, and then fk is mu k, which is 0.2, multiply n, which is f sine 30 plus w, which is 147, cos 30. And then what are we still left with? Equals to f cos 30. So f cos 30, that's what we'll need to solve. So let me erase everything and let's try solve that equation. Alright, so let's see, we can multiply these two into the calculator and say 147 sine 30, and then yeah, let's start off there. So 147 multiplied by sine 30 gives me 147 divided by 2. So can multiply these out. So it'll be 0.2 f sine 30 and 0.2 times 147. 0.2 times 147 gives okay, 0.2 times 147 equals, I'm gonna leave it as a fraction, 147 over 5, because that's 0.2 cos 30 degrees, and that all equals f. Just for simplicity, we'll find out what cos 30 equals to. That's root 3 over 2. Root 3 over 2. Okay, what can we do now? I think we can add these two together since they're on the same side. And we can take this to the other side of the equation. What I mean by that, let me just write it down before it gets too complicated. So 147 divided by, let me undo that, make it clear, divided by 2 plus 147 divided by 5 cos 30 degrees equals f root 3 over 2 minus 0, comma 2 f sine 30 degrees. Yeah, so what I was saying is we can add these two and take this to that side of the equation. That's what we did there. So let's add those two. We get 147 divided by 2 plus 147 divided by 5 cos 30 degrees gave me 98.9611. And then here we can factor out f and have root 3 over 2 minus 0, comma 2 sine 30 degrees, which on that side of the equation will give us, let's work it out with the calculator, root 3 over 2 minus 0.2 sine 30 degrees. That gives me 0.7660. That means that f will then equal to 98.9611 divided by 0.7660, which in turn should give us, and calculate it, 0.766, 129.19 newtons. It's a pretty long answer. Yeah. But let's move on to the next question, which is 2.4. Now let's go to question 2.4, which says a satellite is 1,000 kilometers above the surface of the Earth. It says a satellite that is 1,000 kilometers above the surface of the Earth is accelerating towards the Earth. The weight of the satellite at 1,000 kilometers above the surface of the Earth is 3,800 newtons. Calculate its weight on the Earth surface, on the surface of the Earth. So let's start off by drawing a little picture. So we have a satellite there, we have the Earth there, and the Earth has its own radius, and the distance between the Earth and the satellite is 1,000 kilometers. The radius of the Earth being RE. So the entire distance will be from the center of the Earth to the satellite. That will be, so D will be RE plus 1,000. So they gave us the force as 3,800 newtons. So we have distance above the Earth and force. So because they gave us a force, the equation that I'm going to use is this one under force, which is F is equal to G multiplied M1 M2 over D squared. So if we look at our variables that is given to us with our exam paper, we'll see that G is equal to 6,67 times 10 minus 11 meters squared per kilogram squared. If you ever wonder what units you should convert to, always look at this G variable, it'll remind you. So for mass, we're going to use kilograms. For distance, we're going to use meters. So we have the constant for G, the value of F. M1, we'll say is the mass of the earth. So ME, that's also given to us with our constants, which is 5,98 times 10 24 kilograms. And M2 will be the value we're looking for, which is the mass of the satellite. And our distance we've labeled up here RE plus 1,000. So what we should be concerned with is what is RE, which is the radius of the earth, given to us in our constants as 6,38 times 10 to the 6 meters. All right, to make things more simpler, we can make M2 the subject of the formula. We'll do that by dividing both sides by G and multiplying both sides by D squared, or also dividing by M1. So if we do that, we'll have F times D squared over G M1, and that should equal M2. So let's punch in everything into our calculator, because we got F, we have D squared, which is RE plus 1,000, and then we just have to square it, and then G, we have that, M1, we have that there. So let's punch this into our calculator. So we'll have 3,800 in brackets plus D squared, which is RE 6,38 times 6 plus 1,000. Oh yeah, I forgot to convert that 1,000 into meters. So our distance should be 1,000 times 10 to the 3 to convert that into meters times 10 to the 3 in bracket squared, and G, which is 6,67 times 10 to the negative 11, and then lastly we have M1, which is 5,98 times 10 to the 24. So my final answer for the mass of the satellite is 518.88 kilograms. So now we need to get the weight because they wanted the weight. Calculate the weight, which is W equals mg. I got our m as 518.88, and we know gravity is 9.8 meters per second. That should also be in your constants. So multiplied by 9.8, we get 5,085 newtons. And that is our final answer. All right. So that ends our attempt at the KZN paper for application of Newton's laws. Please do email us, reach out to us. Our email will be in the description. If you have any questions that you want us to attempt, if you have any comments, please write your comments in the comment section, whether it's something small that you didn't understand, or if you have any remarks or praises, we would like some praises too. Also, like and subscribe. That will help our channel a lot so that we could grow this channel and provide more information for you to help you pass. And I hope you the best. Bye.